So, welcome to the second session of software project management. Welcome to the second session of software project management. The previous session we have seen what is a process, what is a software process, what are all the phases in software process models, SDLC. We have seen basic SDLC. What is the purpose of phases in SDLC? We have seen yesterday. The topics what I have covered yesterday is from Unit 2 as well as Unit 1. Very specifically, the titles will be available in Unit 2, but some of the topics are interlinked in Unit 1. Those things we have discussed yesterday. So, commencing with today's content, common software engineering methodologies. So, what are all the methods that's being used? Waterfall model, prototyping, iterative, timeboxing, agile. These are all the models being used actually, or SDLC methods that they have people are using nowadays. Very specifically, since from 2019, I think the Scrum-based management. That's what Agile methodology is. Uh, Much more spread over across the continent. Still, we have other models are in usage, but the reason towards Agile is instead of running with the long meetings, short briefs, and make your own deadline, submit as per the deadline, right? So everything would be on short. If you are going to take a requirement, that requirement should be completed depending upon your timeline. You can fix up the timeline, short timelines. For example, if there are 10 requirements in the project, so one requirement that you can complete within 2 days. So I could be able to specify it within 2 days that I am completing this task. So likewise, I have to mention my own deadline, whether I have met that requirement completion properly. That means verification and validation. Had I made it properly, so those things would be on par. That's the reason why agile methodology is famous nowadays. Rest of the contents that are all in usage, for example, research labs, prototyping and iterative would be that people will be following that methodology because inventions and research, they have a goal. Okay, they have a point to reach. They don't have any saturation for a particular product. That's the reason why incremental model would be more suitable by hybriding this prototyping section. Okay, prototyping means I will make some model. Based upon that, I am going to build the larger component of this model. That's all. Okay, so iterative, the process will be continuing whenever user requirements are not changing. I can go for waterfall model. If I don't find any unstable requirements, okay, if I'm going to find, for example, day by day the requirements are going to change, user requirements are going to change, or monthly some user requirements are going to change, or clients are giving more requirements depending upon the market trend. So on those cases, waterfall model cannot be used. We can go for iterative or incremental model. Either I can go for my agile model. Okay, so that would be the interesting terminology that we have to come up with. So, uh, I suggest all the students that while you are going to do your final year project work, adapt a methodology instead of uh, jumping directly into technical contribution. Instead of running directly into technical contribution, follow the software engineering methodology which has been given towards you. Frame it. Okay, frame it. What are all the phases? What are all the requirements that you are ready to plan? What are all the deadlines that you are going to provide for that? Procedural steps to reach the final outcome. Okay, so everything you can fix up and take it forward your work. Not in a hurry. Okay? Not in a hurry. The last 1 month or 2 months by spending over on tech product spaces that uh, it won't be suggested to take it forward. Okay, so follow any one of the methodology, convenience of your project. That's what in unit one we are having a topic called the categories of projects. What type of project that you are going to adapt based upon that you would be choosing this with. Okay. Even I'll suggest you to use some open source tools to simulate these methodologies. So you can plot those works in the tools. Tools will track you. Okay, tools will send you email. Tools will send you the status of the project. Tools will send you that whether you have met the requirements properly. Tools will inform us that the milestone has been crossed. So everything would be managed by open source tools. Okay. So nowadays, I think for a group of 5 members, that you could able to use it and take forward. The best example is Slack. It's a product from Microsoft. So up to 5 members, the usage is free only. That you can design your model and you can fix up your timeline and map your work with the timeline and model. That's all. Automatically, the things will be carried out and you can move over on that. So even if you want to chat, you can chat in the Slack. So you can create a channel and you can chat itself. For example, if your team consists of 4 members, means you want to subdivide them 2 members and 2 members again. So 2 members can use. You can create a channel for their communication. 2 members could be in a channel, and another 2 members could be in a channel, and timeline can be common for both channels. Okay, that can be linked with your GitHub. So GitHub platform that you could be able to see the product development and the versioning happen over there. So Slack and GitHub can be linked. So that is also we have plugins are available at free of cost only. So there won't be any more regiment on it. No, you can use for up to 5 users at free of cost. So likewise, like Slack, you have a lot of tools are there. You can design up your methodologies and map your work and convey your models and make it to happen. So that's a interesting input that you can take it forward. So running with the model ideas. Okay. So waterfall, I can't go back. That's what they want to convey here. I can't go back means once if I have completed a phase, I can't go back to the previous phase. That's the idea. So moreover, student projects. Student projects means that they have a very minimum time to complete. The requirements are stable. It won't change. A very good example is designing a calculator. Requirements won't change. Very specifically, if you want to go designing a scientific calculator, at any cost, requirements won't change, even if there is invention in mathematics. So that's there the requirements won't change. Okay, so that on these places you can employ this type of model. So as well as I can't comment anything once it is completed. That's what about the feedback. That's a major thing, and that would be the while we are talking about the summary, we will discuss the strength and weakness of individual models, right? So how the process is happening. See, a very important content that you have to understand here is validation and verification. When you have to carry over validation, when you have to carry over verification. Okay. Uh, yeah, yeah, there is a simple terminology that will change the phrases validation and verification. Are you okay? Are you? The simple question could be prefixed with the corresponding activity. Okay, so you can ask that the requirements are right or right requirements are there. So those things will come under this validation and verification. So validating means whether I could able to run with these type of project work or not. Verification is nothing but whether you have met the requirements or not. That's it. That's what the a common embedding terminology that we have to capture up with. So till the phase of coding that you have these contents will be proceeded. Validation and verification will be there in the phases. Okay. So probably till the stage of planning you have the validation. Later onwards, once requirements, if you want to say in the term of software engineering, once SRS is approved, software requirement specification, for any project you will be having in SRS. That is the requirement given by the customer or client. It is stable or unstable, whatever may be. Once it is approved by the project manager and got uh, vetted by the client. Okay, so once both the parties have vetted the SRS, then no need of validation. It's enough to work with the verification. So they have given some 25 requirements. Once the coding is going to complete, whether all the requirements have been met, you can check. Even during the design itself, you can check whether for all the requirements they have prepared the design. Okay, that's the stage. That's a, this diagram will portray something interesting on that. That whether we have how this verification and validation process is mapped with my complete software development life cycle. Okay. And might be you are not I think because in laboratory you will be running with your program and finally you'll go for your documentation, but here for every phase you have to go for the documentation, and even it suggests while you are going to involve in your final project work, you start your documentation from the day one. No need to start from the last day after completing all the work by taking some 6 or 7 days long that people are cranking with the desktop processing and make it to happen. Okay, so that's a very tedious things. That's also will get to go. So to avoid that, what you have to do means from day one, what you have did for today's for the particular project work, what you have did today, like how you are writing a diary. Like this, you make a note of it. That's all. That will serve you as a documentation on later days. Okay, so that's a interesting focus that we need to come up with. So the what are all the outputs that we can expect from a waterfall model? I can expect an SRS, which already I have conveyed you, a project plan, design documents, test plan and reports. This test plan and reports, I think we won't be running more time on laboratory actually. when we are going to work with any online editors, you will come to know about the test plan and its reports. They have some test cases even while you are on your Wipro training. That modules, I think you people have undergone the milestone one test. They have 8 to 10 test cases will be there. You have basic test cases and weighted test cases. You have to clear both the test cases. Okay? As well as we have some boundary test cases also will be there. So basic test cases, weighted test cases, boundary test cases, such that your product is ready to accept any input and respond back. If the input is a valid input, it will process and will give you the output. If the input is not valid or if the input cannot be processed, corresponding or proper message would be given to the end user so that he or she will supply the corresponding proper input for the system. So that's the main role of this test plan and reports. Okay. So final code and supporting documents. So these are all the some good things that we are ready to take over from our waterfall model. So the advantages, it's like what do you call? It's like trial and error approach that we will be running over on that. So you can decide the phases of SDLC here. Okay? That here once a phase is completed, I have achieved a milestone. So I don't want to go back again and to check. Since you have reached the milestone, you have to cross over on the next stage. So the disadvantages is the requirements are frozen, that I can't able to change it back, as well as uh, adapting towards the or upgrading for the new technology. If you want to talk about very clearly, migrating to the new technology. Initially, I did something on my COBOL, Fortran, the old programming languages. Now I want to shift it to some Microsoft technologies or any other open source technologies. The process of migration would be something tough. Okay, it's not about programming languages. The way that I have approached the software development, the way how I have approached. So that tells you the major case. Next, it may be risky because once if I have if any one of the phase has not been verified properly after validation, if any one of the phase is not verified properly, ultimately I think we will lose the steering control. That's all. So where can I use this? That's what. Uh, where I'm going to use my a strict, rigid set of requirements. I should not overlay as well as underlay. In those places, these are very, very well suitable. Okay. Next one is prototyping. So instead of closing the requirements or these requirements, I can build a prototype. When any new requirements are ready to come over on that I could able to replace only the particular stages of requirements. That's all. So that type of possibility can be come over on because prototyping can be performed upon the stage by stage, like our waterfall only. But the case is, I could able to do for each stage, the prototype will reflect the percentage of clearance. Okay, so once analysis is over, once design is over, once code is over, once testing is over, I could able to have a complete impact of all the phases in a single stage. Okay, so whenever I want to do any changes, do the change in the corresponding phase automatically. So I have to start with my initial requirements. You should have some better understanding on development. Okay, so if you want to improve the requirements, you have to get feedback from the users now and then. Probably, I think you could able to see they will be releasing the alpha version and beta version of the software or apps. So when they are going to do that, ultimately it will be from the model of prototype only. Okay. So they will be employing alpha testing and beta testing in the testing phase. That's what. So by using the pre-matured product, that they will be telling that okay, still before it is ready to board the market stage, it might have these changes, these upgrades can be given, so that it will attract more people in the market. So that's what uh, feedback from the users will play a vital role when we are going to work with alpha and beta versions of the software. Okay, so we'll be talking about cost. Cost can be kept low, but nowadays I think you have an investment on the stages or phases of each and every stages of SDLC. So in those cases, I think cost can be low, but can be, for example, you can employ the same person for doing the both the tasks. Ultimately, I can cut my human resource cost. So as well as here, I cannot fix the some short of test cases. That's what they have mentioned very specifically. Exception handling, recovery. These terms are omitted because when requirements are going to change, test cases will be altered automatically. That's the point. So we have the opportunity to scale our issues. I could able to modify the sections now and then. User engagement is more. That's the point here. That's what getting feedback from the user will convey that okay, this is the requirement I have given. This is the requirement that you have developed. Actually, I was expecting this requirement. Likewise, we can get a feedback from the customer. It was being received. It's well and good. Once if everything is being launched, I think you can check with the app store that will be telling that this app is useless. This app is very worst. Initially it behaved worked well and good. Later it's showing its original intimacy. So likewise people will be passing comments, right? To avoid that, user engagement would be very good when the product is on field. Okay, so cost and schedule, because when requirements are going to change, but mostly it will take our time. That's what the issue on schedule, as well as when time is going to increase, I have to invest on people and other infrastructures automatically. That's what the stage of prototyping that people will be talking about. Okay, so that's the interesting discussion on that. So where I can use where you feel that the uh, requirements may change, right? Even though they have given these things today, the requirements may change. Likewise, if you feel in those places, it is better to employ this type of prototyping model, as well as they have given variants means types of models that you're able to run over. How can you build up your prototype? Right? You can build up your paper model, or you can go for a UI based prototype, only screen designs. So technology proving that create some working model, a small working model. Okay? So rapid prototyping environments. So I can go for some what do you call wizard based creation directly. So those things will be the variants for prototyping. So a very good example for prototyping for wizard based one is initially we have C++ Visual C++ environment would be there. So I could able to plug and play the contents and do it neat and clean. Later it was converted as our Visual Studio.NET platform. So the application development environment would be something very convenient. So within a short span, I could be able to create a complete application. That's also be a interesting variant on prototyping. Iterative development. Okay. Whenever that every iteration is going to complete, I can get a feedback. That's what. The difference between prototyping and iterative will come over like this. There, I don't have any iterations actually. It means I don't have any particular section. After completing a stage, here in each and individual stage, I can go for iteration. For example, I'm having my requirement stage. I can refine my requiremements by running some 2 to 3 iterations for reaching my requirements. For example, I'm going to develop a reservation system, okay, for your travels. So what are all the requirements? I could able to list it out. I could able to list it out the set of requirements along with my client. Next, users of the corresponding client. For example, Redbus is my client means users of Redbus. I can have a see now we are going to migrate to this type of reservation system. These are all the requirements given by the Redbus. What's about your opinion? Whether these requirements are enough or any other requirements that I could able to add up with? That's what the second iteration will be happening. Next, the third iteration. Third iteration would be with the tech people. That these are all the requirements being given by the people. Now they are going to validate the requirements. Okay, feasibility study whether these requirements are ready to can be seen in real or not. Okay? Can be seen in real or not. So can we visually could able to see it and activities of those things can be performed or not. So that's a interesting iteration that I could able to run over within a single phase. Within a single phase. So I can run, I can complete it. Then I could once if I have completed, I could able to come over on it. Even if any new requirements are going to come, I can go back to that corresponding iteration and again I have to iterate from the beginning. Please remember that I can't come towards the end of the iteration and I have completed. I am in a new iteration. Once iterations are going to complete, I could able to go back to the when the incrementation is going to happen or decrementation is going to happen. I could able to come back and work from the beginning of the iteration again. So that's the fine tuning can be happen in every stages. That's the interesting section, and this is the base model for all types of existing SDLCs. Very good example is Agile. So here the iterations are not linked in Agile. That's the major advantage of Agile. Okay, say I'm running iteration one, iteration two, iteration three, iteration one with the clients, iteration one with the users of clients, iteration three with the tech tech people. So I can run this iteration parallelly. Okay, I can create a summaries parallelly. I can communicate to the three teams parallelly. So through that, their requirements can be checked parallelly. That is the advantage of Agile over there, since it is based upon our iterative model. Okay, as well as the very good idea here is quick response should be there. That's a point to be noted here. Quick response would be there. So the cost section, you want to say very clearly, billing section. This had created a trend in the client environment as well as when a big MNC is going to outsource the project work, the product development, their billing will be released based upon the completion of iterations. Even they will execute the bond based upon these iterations. So iterative model, something interesting to work with, but the drawback again the cost. Benefit I could able to talk about, but as well as drawback. The number of iterations are going to increase. Ultimately, cost will increase. Okay. So as well as I cannot fit any type of architecture for this project, this model, because we have the types of software architecture, function function call call and return. So these type of architectures I could not able to fix it up for this SDLC model. Okay, there are 5 types of software architectures available. Such those architectures cannot be fixed over. That's a major case. Even I could convey that it may be object oriented paradigm, iterative model. So probably on real time projects that it would be more useful. That's what where response time is important on those places that I could able to move for this type of model. So we have to take care for the length of the iteration. That's what people will be running over on that. Yeah, either even you can substitute any models here also. For example, in this particular iteration, I can follow a waterfall model. This particular iteration, I can prototype it. So likewise, you can fix up some hybrid models within the iteration. So that's also being possible. Time boxing. Time boxing is nothing but it's purely talking about timelines. Okay, iterative development. In normal iterations that uh, till we are reaching the saturation, I could run the iteration. But here there would be a timeline. As well as one more point is going to ready to insert here is pipelining. Pipelining means connecting the iterations. That's also being introduced officially here in time boxing. Right? These are all the things I have taken for Agile. The best features of all the models are being combined and given for Agile actually. So that you could be able to see the connectivity happening between different iterations. Okay. I think in the second image that you could be able to see the pipeline time boxing. When the first team is in the build stage, second team would be running over with the requirement stage. Right. So when you are going to run with 4 iterations, if you are having 4 different teams to manage, then it's good. It would be rapid like anything. But the corresponding input will be received from the previous iteration. Please remember that. There would be a connectivity happening between the iterations. That is the reason why pipeline was introduced here. So you can fix up the iteration duration. That's the major case in our time box. Even you can adjust if it is necessary. So while the timeline is going to complete, make sure that the deliverable is ready. So linear time boxing is nothing but once an iteration is completed, the output of the first iteration will be given as input for the second iteration. That's all. That is what linear time boxing. I have to wait. The time won't be changed over the pipeline is nothing but that parallelly it will happen. You have seen it through diagram. A lot of things. So this one already we have seen, especially for implement the concurrency, where I could be able to use this. So they are talking about team size here. The reason is when we are going to employ more number of people, more iterations are going to come. That's all. That's the case. Group's law. Okay. So adding manpower to a late software project makes it later. Okay, so that's an interesting myth actually. Even if it won't be a law, they will say that it is a myth. So by increasing the team size, you can't reduce the cycle time. Cycle time means if I need an input from the previous stage, I have to wait, right? So even if you are running parallelly, for stage 1 to stage 2, stage 1 will complete its second phase. Output of the first phase will be given as the input for the second iteration as the first stage. So on this time, I have to wait. So there will be a notable or there will be a propagation delay, measured propagation delay will be there. So you have to wait for that. Okay. So how you are allocating the work for the corresponding teams. Even work allocation can be had through cycle model. This is what I will be conveying for your project work. If you follow your model, you can allocate the model for all the phases of work. That would be the applicability where I can use this. When you are going to get within a short deadline, you want to complete your project, you can use this. That's a major thing. When big teams are going to come, might be the task will be finished easily, but cost will be higher. As well as when the teams are going to big, when the iterations are going to increase, synchronizing communication between teams would be a complex one that we have to take a measure, or we have to fix up a pool to communicate. Okay, so process models will define me the general process. Every process will have the individual stages. I have to use my models for the development. That's a major thing. So this is what we have seen. So the strength and the weakness. It's very simple, but where it will come when requirements are going to change, ultimately I could not able to do it. I could able to use it only for projects which don't have change in requirements. Prototyping. So it's very good for stable system as well as when requirements are going to change, I have to change the individual stage prototype. That's what the major on this. So best thing is I can the advantage here is I could able to see my prototype, a basic working model in vision. So user interaction is the main point here, as well as the process of verification and validation will fine tune this iterative model. Time boxing will work with deadlines along with the features of iterative model. Okay, so that's the discussion. If you have any clarifications, you can raise.